8.2. Solving absolute value equations. We will be solving absolute value equations both graphically and algebraically. There are two cases when we're solving the equation algebraically. The expression inside the absolute value is positive or 0, and the expression inside the absolute value symbol is negative. So if I said the absolute value of x equals 7, that means that x can equal positive 7, or it can equal negative 7, because if I substitute negative 7 in for this x, the absolute value of negative 7 is 7. So that means that that equation, that would be a potential solution for x as well. So let's just see how this all works out graphically. So I'm going to first graphically solve this. So the step number 1 with graphically is graph y equals 7, which is just a horizontal line at 7, and the absolute value, y equals the absolute value of x minus 3. So since the absolute value of, or y equals the absolute value of x minus 3 is a little bit trickier, I'm going to do that first. And I'll just go through the steps on how to graph an absolute value function again. You have x, and we have y. We know that there's no squared on here, so we are going to, we know that that's just going to be a line, which in absolute value means that it becomes a v. So if I were to graph this, graph the line y equals x minus 3, I'm going to give my scale here 2 and 2. Negative 3 is my x-intercept, and I have a slope of positive 1, up 1 over 1, up 1 over 1. So if I were to graph this thing, like that. However, everything that is negative, or a negative y value, or below the x-axis, that becomes positive. So then this is 2 comma negative 1, that becomes 2 comma 1, and so on. So I'm just going to use my red here to show what the actual absolute value is. Just going to extend this just a little, and I'm going to actually erase this line, because that was just kind of our helper line. Now what we also need to do is we need to graph the line y equals 7. I can do that in blue. 2, 3, 4, 5, 6, 7, right here. So 2, 4, 6, 7, perfect. So we say that the solution is where these two lines cross. And it's just the x value of where they cross. So the solutions are the points of intersection, identify the x-coordinates. So before I do this, I'm just going to label this. So this is y equals the absolute value of x minus 3. And this guy right here is y equals 7. So I would say that the x values of the intersection are negative 1, negative 2, negative 3, negative 4. So x equals negative 4, because that's the x value of this intersection. And we have 2, 4, 6, 8, 10. And we have 10 as a value. So that means that in this equation right here, if I were to substitute in negative 4, I would get 7. So the absolute value of negative 4 minus 3 is negative 7, but the absolute value of that is 7. Great. And if I were to substitute in 10 for my x, 10 minus 3 is 7. The absolute value of 7 is 7. Great. So graphically it can be done, however it doesn't give us an exact solution sometimes. Algebra, solving it algebraically will help us get the most accurate solution. So solving absolute value equations graphically sometimes only gives us approximate solutions. To find exact solutions, solve algebraically. To solve absolute value equations algebraically, use the definition of an absolute value to create two linear or quadratic equations. So if I were just to write this down, x minus 3, the absolute value of x minus 3 equals 7. I need to take this in two chunks. I need to solve this for when this bracket right here becomes negative 7, because the absolute value of negative 7 is positive 7. And I need to take another solution here where x minus 3 turns into actual 7. Now we know that the solution for the negative is 4 and the solution for the positive is 10, but I'm just going to show you algebraically how to do it so that so that we can confirm our findings. So what I need to do is first I need to isolate the absolute value. And then what I need to do is to set one side of an equation. I need to set one side of an equation. I need to make it negative. Okay, so the easiest way to do that is to switch the fewest amount. So I'm going to keep this, I'm going to keep the x minus 3, and I'm just going to say x minus 3 equals negative 7. Now I could do it. Okay, I could do it. I'm just going to go off to the side here. I could say that negative x minus 3 equals positive 7, and then I would distribute happy little rainbows, negative x plus 3 equals 7. But I think that you can all see how this can introduce so many possibilities of error that it's easier to simply make it negative 7 here. And then I'm going to keep this to x minus 3 equals positive 7. Why? Because the absolute value of negative 7 is 7. So this will be true. So now what we do is we solve both sides, add 3 to both sides, x equals negative 4, and add 3 to both sides here as well, x equals 10. I'm going to put a box around my answer because I like my teacher. The final step here that I didn't write down is solve each. Great! So here we are to the next question. Solve 6 minus x equals 2, both graphically and algebraically. So I'm going to set it up. So I have y equals negative x plus 6. See the negative, it comes before the x, so I put it here, and there's an implicit positive in front of the 6. So I've just changed the order, and so that's y1, and then I'm going to say y2 equals 2. So that's a horizontal line at 2. So let's set up our graph here. Label our axes, x and y, 2 and 2. That kind of looks like blob, not 2. There we go, that looks better. And let us draw this first one here. So x minus 6, negative x plus 6, so 2, 4, 6, this is where my b is going to be. And I have a negative slope. So we're going to go like this. And this one goes up like this. Perfect. Now I am going to create my absolute value from that. So anything that is, and I'm going to finish this one up in blue. So anything, this is positive 7, negative 1, so that becomes positive, 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 positive. So I'm just going to connect these dots here. And I'm going to connect these, just go over them. And I'm going to label my graph here, y1 equals, and I'm just using 1 and 2 subscripts just so that I don't confuse the two, just keep them more separate. So that is the absolute value of x minus 6. Now what I will do is I will simply erase this line because that was just a helper line to begin with. Now I'm going to switch to red. I'm going to graph y equals 2, which is just this horizontal line right here. Lucky for us, they connect at exact places. So here and here. So we know that x equals 4 and x equals 8. Because the x values of these two intersection points, which by the way are 4, 2 and 8, 2, the x values for them are 4 and 8. So graphically done. Let's solve this algebraically. So I have the absolute value of 6x, sorry, not 6x, the absolute value of 6 minus x equals 2. Remember, I need to take it in two chunks, one where the 2 is positive and one where the 2 is negative. So I would say 6 minus x equals 2 and 6 minus x equals negative 2. Remember, it's easiest to just make one term instead of distributing the negative to both of these terms. So I'm just going to add x to both sides and subtract 2. So this becomes 4. So x equals 4. And I'm going to add x to both sides, and I'm going to add 2 to both sides, so that becomes 8 equals x. So I have two solutions. Now let's just see if this makes sense. That's always important. So if I would just say 6 minus 4, the absolute value of 2 is 2. Good. If I were to put in 8, I would say 6 minus 8. That's the absolute value of negative 2, which is positive 2, so we're good.